Mr. Wennis, this is Benjamin Sims. Today I'll be performing the selection sort. How selection sort works is that we have two cursors in a sense, where they both start pointing at 7 in this case. How this works is that it shows you that this is the current minimum value. So to show this, we're going to put 7 further up, just to indicate that it's the current minimum value. So then we compare 7 with the next. Now this case is 10 is bigger than 7, meaning we do not put this higher and put this lower. We just keep this the same. So this is still the current minimum. Then we move up to 8. 7 is still bigger, is still smaller, so we do not change the current minimum. Now on to 4. 4 is smaller than 7, meaning this is the new current minimum. We'll get back to that later. Now 5 is bigger, 6 is bigger, 10, now 2. 10 is smaller than 4, meaning 2 is the new minimum. Then 5, then 7. So, searching through this entire algorithm, in a sense, array list or deck of 10 cards, 2 is the smallest. Meaning, we then bring the 2 over here and swap places with 7, with the first 7 at the beginning. Now, this 2 is considered sorted. Now we start again. 10 is the minimum. Now 8 is the minimum. Now 4 is still the minimum. Still 4, still 4, still 4, still 4, still 4, still 4. Okay, now we go back and swap these two. So now 4 and 2 are sorted, and we still have the rest of the list to go. 8 is the current minimum. It's still 8. It's now 5. Still 5. Still 5. Still 5. This is the same value, but since it doesn't apply to it being bigger or smaller, it's as if it's bigger. So this 5 here is still the minimum value. Then we move on to the 7, and it's still the minimum value. Now we swap the 5 and the 8. And now this is sorted. Again, 10 is the minimum. Now 8 is the minimum. Now 6 is the minimum. Still 6. Still 6. Now it's 5. And it's still 5. So now we switch. Now 8 is beginning again, and this is now current minimum, still the minimum, still the minimum, still the minimum, still the minimum. Swap. Now this is all sorted over here. Now 8 is the current minimum. 8 is smaller than 10. 7 is smaller than 8, meaning 7 is now current minimum. 7 is smaller than 10. 7 is the same, but in this case, it's the current minimum. Now, 10, 8, still 8. Now it's 7. We switch, and now it goes over here. 8, 10, 10, 10, and now we bring these two over here. The time complexity of a selection sort is n squared. In this case, it will always go through n squared amount of times, meaning it doesn't have a worst case, a best case, or an average case. It is all currently the same. So, with this being said, it's an unstable sorting algorithm. Thank you, Mr. Wennis.